Hello everyone. Here I want to find the expression of x to the power of 100 plus 1x to the power of 100 by considering of this expression. To do that, at the first step, I can square to the both of these expression x plus 1 over x square equals to the square root of 3 to the power of 2. For the left side, you know from the mathematical identities, if a plus b gets raised to 2, it will be equal to a squared plus b squared plus 2 times a b. I can use this identity for the left side of this expression. Okay, I can use that here. Now, considering this identity, the first term squared plus the second term squared and plus 2 times first term times second term equals to, for the right side, the square will be removed with the radical sign and we just have 3 here. I can simplify this, from this one is square root again, but for this one you can numerator and denominator the different as different terms get squared. So this one squared is just 1 and denominator is again x squared. Here you can simplify x with this x, so we just have 2 and here is 3. I can take this 2 to the other side with flipping the sign, so it should be minus 2 and we have x squared plus 1 over x squared is 3 minus 2, which is 1. This is the first result we have from our procedure. I just make a line over it so we can use that in the future. As the next step, I just drop it here, and again I can come back to the main expression, but for now I can get raised it to 3. X plus 1 over x cube equals to a square root of 3 to the power of 3. And we have another identity here. Formula here is, I can write it here. A plus b to the power of 3 is equals to a3 plus b3 plus 3ab times a plus b. That is the another formula for our procedure. If you want to see another examples from these useful identities, you can subscribe my channel and you can find a lot of expression, a lot of problems, and in every single problem I can explain these identities and these formulas, important algebraic identities there. So by using this I can again come back to the main problem, main procedure, and I can find it by this identity. The first one, cube, plus the second one, cube, plus 3 times the first one times the second one and times summation of these two terms. And for the right side, you know, when you have any radical expression to the power of 3, you can write it like, because it's you can write it like a3, and that is a squared times a, and it could be written like a times square root of a. Now I can use this radical formula for the right side of this expression. So here I can write, instead of square root of 3 to the power of 3, like 3 square root of 3, by considering of this formula here. Now I can simplify it more. It's equals to x3 plus, again, numerator to the power of 3 is 1, x3 in denominator, plus x simplified with this x, and we have 3 times x plus 1 over x equals to 3 square root of 3. And you can remember this expression here, x plus 1 over x, is the main expression we proposed from the beginning of this problem. It equals to square root of 3. I write it here. This one is from the beginning proposition is square root of 3. So I can write it here. I can simplify it, maybe here. Now is x cubed plus 1 over x cubed, and here plus 3 square root of 3, and the other side is 3 square root of 3. And you can simplify these two terms and nothing will remain. And finally here is x cubed plus 1 over x cubed equals to 0. Okay, this is the another result, but we can multiply both sides of these terms to x3, and we can lead to this, because x3 times x3 is x6 plus, and 1 over x cubed times x cubed is just 1, and 0 times everything is, is 0. And so by taking out taking this 1 to the other side, x6 equals to minus 1. This is the another result we can use to find the main problem we asked from the beginning. So, but how? What we want here is x to the power of 100. But you can get raised x6. I can write it here and I can show you the procedure. x6 is minus 1. But if I get raised to both sides to 17, then x to the power of 6 to the power of 17 is x to the power of 102. Just 2. It's not exactly 100, but it's very close to the 100. So we can continue from this procedure. And for the right side is minus 1 to the power of 17 because this is the odd number. So minus 1 to the power of 17 is simply minus 1. Okay, now we can divide, if I write it here, the result x 102 is minus 1. If I divide the both sides to x squared, then I have from the left side 102 over x to the power of 2 is x 100 exactly, and for the right side I have minus 1 over x to the power of 2. This result, and you know, if you inverse the both sides, you have 1 x to the power of 100 equals to minus x get raised to the power of 2. You can see here x 100 is minus 1 over x squared. By inversing the both sides, you have 100 1 over x to the power of 100 equals to minus x squared. So you can find the main problem we asked at the beginning. X 100 plus 1 over x 100. Very simple. We can just replace these terms here. X to the power of 100 is minus 1 over x squared, and 1 over x to the power of 100 is minus x squared. By factoring out just this minus, you have 1 over x squared plus x squared. But you can remember, we have this number here. We have this expression here, which the summation of these two terms are just 1. So you can replace 1 here. So it will be minus 1. So the result of x to the power of 100 plus 1 over x to the power of 100 is minus 1. And this is our last answer here. Thank you for your attention.